Going over LeetCode 49, group anagrams. Given an array of strings, group the anagrams together, and we can return the answer in any order. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all of the original letters exactly once. So in example 1, we see that our input string array contains the words eat, tea, tan, ate, gnat, and bat. And the output is going to have several sublists, the first one being bat, the second one containing gnat and tan, because these two are anagrams in which they share the same letters. We see that there's one count of N, one count of A, one count of T, and the same for this word, one T, one A, one N. And our last sublist is going to have 8, eat, T, where every word in this list contains exactly one A, one T, and one E. And so now that we know what anagrams are, let's solve this problem. And the approach I took was I utilized a hash map where the key of the hash map is going to be a string representation of the count of each character in a given word. And its associated value is going to be a list of strings that are going to contain the anagrams. And the first thing we must do is iterate through the provided string array, where I used a for each loop. And within the for each loop, I had to initialize a array to represent the unique keys of the anagrams. And so we see that I have an integer array called count, size of 26. The reason why it's size 26 is because there are 26 letters in the English alphabet. And when we initialize this count array of integers, it's going to be of size 26, but at each indice, every element is going to have an element value of 0. And so that means that there's 0 counts of a given character right now. But as we proceed, we'll see that'll change. And so the next step to take is to iterate through each character within an individual word. And I did that using a for each loop as well, where we look at each character within a word by using the toChar array method. And within this for each loop, we have this line of code, count C minus A plus plus. To understand this, we have to understand that in Java, characters have an ASCII value, where the ASCII value of lowercase a is 97, and the ASCII value of lowercase z is 122. And the ASCII value of b is going to be 98. And so to give a little example to understand this line of code here, let's say that the given character we're looking at, that we're iterating through, we landed at a character B. And the ASCII value character of B, like I said earlier, is 98, and A is 97. So if we have B minus A, that's 98 minus 97, that's going to give us 1. And so if we have 1 here, and we're looking at count, looking at its index of 1, that means we are looking at the index representation of B. As previously stated, this count is of size 26, where index 0 represents A, index 1 represents B, and so forth. And for a little more context, let's say we're looking at C, and it represents the letter A. So if we have A minus A in ASCII value terms, that's going to be 97 minus 97. And so we'll be looking at count, index value, index of 0. And like I said earlier, index 0 of count represents A. And so the plus plus is going to increment the actual value at a given index. So using that same example, if we have a minus a, that's going to, in ASCII value terms, give us 0. So we're at index 0 of the count array, and then we're going to increment its value by 1. So if its current value is 0, plus plus means that it's going to be 1, which means we have one count of a. And so once we are done iterating through all of the characters in a given word, we are going to generate a key representation of that word. And to do this, we're going to call the method arrays.toString on the count array. And if our count array, currently our count array, for example, is going to look something along the lines of, just as a arbitrarily example, it's going to look like something like this. Could look completely different, but that's what it looks like right now. And so when we call this method on our count array, it's going to put it in a string representation under the variable called key, and that's going to be the key in our hash map. And once we have that key generated, we're going to check if our hash map already contains that key, and if not, then we're going to add that key to the hash map and instantiate a new array list as its value, an empty array list. And once that is done, then we're going to grab that key and add the word associated with that key. So, for example, if we have the word be bad, its count key representation is going to look like, so it's 1 count of A, 1 count of B, 0 counts of C, 1 count of D, and then a bunch of zeros. That's what it's going to look like as our key representation. And so once we add it to our hash map, it's going to have this as its key, and then it's going to add bad to its array list. And if the key already exists, meaning we've already encountered a word with the same letters and same count, we'll just straight up add that word corresponding to the key. And once we have iterated through every word in the input string, then we can just return an array list representation of all of the hash map's values. Now the time complexity of this program is going to be big O of m times n, where m represents the average length of each word within this string array. And then n is going to represent the length or the amount of strings within the input string array.